Hello sir, good morning. Good morning to my good afternoon to my classmates and to our professor Sir Gideon Rabillas. So I'm going to report sir my assigned topic. So this is under our subject MITS 101 data mining. So I am assigned to report for module 1. This is all about federated learning and privacy preserving data mining. So we have federated learning and privacy preserving data mining. So this is my subtopics. And second, we have mining distributed data without centralization. And what are the applications in healthcare, finance, and also in Internet of Things. So again, good day no sa atong tanan. So today we will learn about federated learning, no? So this is very important in areas like healthcare, finance, and IoT, no? Where privacy and security are critical. So by the end of this session, you will understand how artificial intelligence can learn collectively while protecting sensitive information. So I am your presenter, James Calvishikanya from Ormoc City, and currently pursuing MSIT under batch Abelia. Okay, so before we will proceed, let's go over the objectives of today's session. So by the end of this session, you'll be able to understand why centralizing sensitive data can be dangerous and learn the federated learning, the concept of federated learning, explore privacy, privacy preserving techniques such as differential privacy, secure multi-party computation or SMPC, and we have homomorphic encryption or the HE. And we're able to identify the applications in healthcare, in finance, and in Internet of Things. And then the fifth, we can recognize the benefits of FL for privacy, security, and collaboration. So next, why not centralize data? So traditional data mining, it says here that it requires collecting all data in one location, so which can be risky, no? So centralizing data increase privacy risks, information can be exposed, security threats, one central storage can be hacked, or regulatory issues, no? Like HIPAA or GDPR prevent sharing personal data freely. So we can imagine, no, in several hospitals, just like for example, they want to build a predictive model for disease detection and then sending all patient records to a central server. It could violate privacy laws and risk the patient data. Moreover, if the server is hacked, so all the data could be stolen at once, so nalisod. And then that is why we need methods like FL, no? It allows artificial intelligence to learn from distributed data securely and keeping information private and legal. So what is federated learning or FL? So this is a training machine learning models across multiple devices or servers without centralizing data. So how it works, each local device or server trains a model on its local data. Only model updates, not raw data, are shared with a central server. The central server aggregates updates into a global model. and then a global model is sent back to the local devices for further training. No? So federated learning works like kini ang everyone cooking the same recipe in their own kitchen, no? So like for example, each person experiment and improves the dish, but instead of sharing all the ingredients, they share only the changes. So similarly to artificial intelligence models, they learn collectively from distributed data without exposing the sensitive information. Okay? So these are the privacy preserving techniques. So we have the DP, or the differential privacy, and then we have the SMPC, the secure multi-party computation, and then we have homomorphic encryption, or the HE, no? So to keep the data private, no? So FL, or the federated learning, uses these three main techniques, no? So you can imagine, no, this as a mask, no, mascara or lock boxes. So they allow artificial intelligence to learn useful information, no, without exposing the private data. So we will go through each technique with examples and analogies to make it easier for you to understand, no? So we have here the differential privacy, or DP. It adds random noise to output so individuals cannot be identified, and then it preserves overall patterns and trends, no? So it's like a differential privacy, no, works like adding a bit of fuzziness to the data. And then even if someone tries to identify a person, the noise makes it impossible, no? So for example, the Apple uses differential privacy to improve predictive text. They only learn general patterns of typing, but not your specific words. So this protects privacy while still producing useful insights. Next, we have the SMPC. So the SMPC, is the multiple parties can jointly compute results without sharing private data, no? So SMPC enables organization to work together safely, no? And then for example, no, several banks can compute average credit scores without sharing individual customer data. So each bank contributes partial numbers, and the final computation is correct without revealing private information. So that's for secure multi-party computation, or SMPC. Next techniques is the homomorphic encryption. So it allows computation on encrypted data, no? So data stays hidden, only the final result can be decrypted, no? So ni siya ang HE, or the homomorphic encryption. So this is very useful for extremely sensitive data. So just like for example IoT sensors, no? IoT devices can send encrypted readings to the cloud, while the calculations like averages or totals are performed without exposing the real data. So meaning to say, only the owner can decrypt the result, ensuring privacy and security. So that's homomorphic encryption. So next we have the applications of FL in healthcare, no? So applications in healthcare, collaborative disease prediction without sharing patient records, and then local models trained on hospital data, aggregated into global models, which complies with Health Insurance Portability and Accountability Act and other privacy regulations, no? So we can apply it in healthcare, no? So it lets the hospital to collaborate without moving sensitive patient data, no? So these models can improve as more the data contributes to learning, but the privacy is maintained. So this ensures compliance with privacy laws, no? And also it improves medical decision making. Next, application in finance. So FL application in finance, it detects fraud patterns collaboratively. So it customer data remains local, and then the aggregated insights improve fraud detection algorithms, no? So for example, no, banks can work together to detect fraudulent patterns without revealing customers personal information, no? So the FL learning allows them to share knowledge safely, creating stronger and more accurate fraud detection models. So that is example application in finance. And then another application for in Internet of Things ecosystem, or the IoT, no? Like smart homes, wearables, and industrial sensors can learn locally, no? And then only aggregated insights sends to cloud, no? For example, smart devices, no? Like thermostats can learn from usage patterns without sending raw data to the cloud, and then making them intelligent while preserving the privacy. So what are the benefits of federated learning? So here we have protects privacy and security, ensures regulatory compliance such as the privacy or data privacy, no? And then it enables collaborative intelligence across organizations, and then scales across multiple devices and servers, no? So these are the benefits. So this it is more than just a technical innovation, no? It is a trust solution. Organization can harness distributed data to improve artificial intelligence models while keeping sensitive information safe and staying compliant with the laws. So to summarize, so federated learning enables AI to learn collectively from distributed data while keeping sensitive information private. While the DP, SMPC, and the HE, it ensures security and privacy. So this approach represents the future of collaborative and ethical AI. So these are my references. That's all, sir. Thank you for listening.